Since this chapter is about calculating how many, we're going to have to spend a little bit of time talking about how many moles of dissolved ions we get. This is an example that comes in your book from page 420. And we're going to talk about a couple little quick examples here. First of all, the dissociation of sodium chloride gets us sodium and chloride ions. Now, if you had 1 mole of this, you would get 1 mole of these ions and 1 mole of chloride ions together. That would make 2 moles of ions. So we could have a 1 molar solution of sodium chloride, and we would get a 2 mole solution of ions. What about something like calcium chloride? Well, calcium's a 2 plus, and chloride's a -1. So to balance this formula, I need to have 1 calcium and 2 chloride ions. So we will get calcium plus chlorine. And to balance my formula, I'll still have 1 calcium, but I'll get 2 chloride ions. So that means if I had 1 mole of calcium chloride, I would get 1 mole of chloride ions, and I would get 2 moles of chloride ions. So together, these would make 3 moles. So whatever impact is happening on solution, we would get 3 times the effect because of 3 moles than we would if it was a 1 molar solution. Here we get double, triple. And what about this guy? If we had a 1 molar solution of this, why, we'd have 1 mole of that compound, aluminum sulfate. We would get ions, aluminum 3 plus the sulfate, so the 2 minus. And how many of these would we get? Well, we would get 2 of those and 3 of these. So 1 mole of this would give us 2 moles of aluminum ions and 3 moles of sulfate. Altogether, that would get us 5 moles of ions impacting something. Whereas compared with if we were to have sugar, and there's many different sugars, if we had a 1 molar solution of sugar, it does not form ions. It doesn't ionize, it doesn't dissociate. And so we would get, if we had 1 mole of sugar, we would get on the other side of the solution, we would get also 1 mole. So the impact would only be 1, whereas some of these others would be 2, 3, and 5 times as much of an impact on the ionization process or the colligative property.